So hi everyone, thank you for attending this session, and I think it's time for us to start. And the first presentation is by James about dynamic everything.
All languages are dynamic, that's right. My text today actually comes from Douglas Copeland's novel All Families Are Psychotic, where I think he's actually riffing on the famous quote, it's not Dostoevsky, of all the families being, all unhappy families are different in every way, but all the happy families are the same. What's that got to do with programming languages? We might get there, I don't know, we'll see. Why on earth would I say all languages are dynamic? Because that's clearly stupid and clearly wrong and clearly not true. Well, once when I was younger than anyone in this room, I can still remember sitting in my bedroom reading this book, the ZX81 Basic Programming Manual, because I had a computer like this, the ZX81, which had 1K of RAM, and 1K of RAM lets you write more or less one screen worth of programs, and I have to stand here or the camera won't pick me up. So this is actually ZX81 Basic. There's a bunch of stuff I could talk about that, notably how it was impossible, for example, to make a syntax error. Who thinks that being able to make a syntax error is an important part of a language being dynamic? Is that everybody or nobody? Because you couldn't make a syntax error. The reason is because that little K there meant keyword, and when you press the key on your keyboard, which I don't have a picture of, sadly, it would jump up and say, actually I don't know what it would jump up and say, because I can't remember the basic keyword that began with K, but if you hit P, you got print, and if you hit G, you get go to, and what this was actually doing was translating your key presses into what we could almost call bytecodes, and sticking those bytecodes into memory, and then the way it drew that was it actually ran through what you could think of as bytecodes and printed the damn bytecodes to the screen. So it was a print bytecode in memory followed by the bytecodes for that temperature converter. This just came off YouTube or, whatever, Wiki. So, is this dynamic? It felt dynamic. When you ran your code, you had a slow mode where it would keep the picture in a fast mode because it was using the main CPU to draw the picture, so most of the time the thing was only ever drawing the television picture. And it just stopped drawing a television picture and computed 20 times fast, which was really rather slow, of course, these days. But anyway, as an aside, looking at this code, type declarations. Are languages with types declarations, static type declarations, dynamic? Who thinks that you can't have static type declarations and have a dynamic language? Come on, this has got to be easy, right? Anyone? Yeah, who thinks you can?
The question again?
Can you have static types? Because really, let's face it, this is what it's about, isn't it? Really what this entire symposium is that people writing papers about small talk and about Perl or whatever couldn't get their papers into the main conference. And you might think that's funny, but if you really, really want to see something funny, I recommend going to YouTube and typing Popple the next 50 years. And listen to a panel at Popple this year where the panelists go through the list of the famous papers, like separation logic, like typed assembly language, and there are several others that get mentioned by name, all of which were rejected from Popple, and all of which the Poppleites are really proud they rejected them, because they could rebuild all that work based on true Popple foundations. That, ladies and gentlemen, is why we are at Uppsala and not at Popple. But why are we here at Dynamics? So where do we get to? You know, like type declarations bad? Yeah. Static types bad? That's the point of this, isn't it? Because you couldn't get a paper into the main conference. Okay. What about that? Is that statically typed or dynamically typed? This is basic. Come on, it's literally basic. It's basic in at least 3 different ways. Untyped. We have an untyped from Jan. Who else?
Dynamic.
Typed. Yes. Manuel wins. Yay! That's right. Basic is a statically fucking typed. Sorry, statically. I'm not in America. Statically is a fucking statically typed language. All right? Because you can see the types because that's what these things here. I had a conversation with all those dollar signs, and if you're into a more sophisticated basic, you might get percent signs as well. which means that you've got an integer variable instead of a float. And even in ZX81 basic, it's not shown there, you have to declare your arrays before you use them. I know that's a difficult concept for Python programmers to understand. You can't just, or Perl programmers, you can't just start subscripting stuff and it manually creating all these variables. Fortran programmers may have difficulty with that as well, but in BASIC you have to declare everything. And the original basics, I don't know if you count if this one's being compiled, but you're not running the code, we're running bytecode in the original basic, and the VAX basic that I was forced for some stupid reason to do at university was all compiled. It was compiled line by line. You could call it a jitter perhaps, or a dynamic compiler, but it sure as hell was compiling. What about that? Anyone know what this is? I never used it, but I'm sort of just gesticulating to Niklaus Wirth and... It's not RAT4. Where's Robert? That sounded like Robert. It's not yeah, it's RAT4. That's right. With the spirit of the, what is it? This photograph was taken from a Canberra tweet stream. Yeah, it's RAT4. It actually, it might be fucking RAT4. I just grabbed the thing. It is, isn't it? I was going to say this is Pascal, but it's not. It's actually RAT4. One of the things we've already heard about is that dynamicness is about being open to the environment and being able to take advantage of serendipity in the programs you write or the talks you give. So yeah, you're right, that is RAT4. It's actually RAT4 apparently running on the UCSDP system. If you know what the UCDP is, if you were older, in New Zealand case we couldn't afford the computers, but if you were slightly older than me, you may have learnt your Pascal programming on this thing, which was a bytecode interpreter that ran on Apple IIs and various other bits and pieces. The UCSD Pascal bytecode interpreter was one of the 3 alternative operating systems that was available when the IBM PC launched. What was it? It was a bytecode interpreter. Static or dynamic? I don't know. This is RAT4, same thing for Pascal. The user interface there was called the filer, and not long after that, when the Macs came out, they changed the name of the interface to the Finder. So in fact, that thing across the top is arguably the ancestor of Mac's menu bar and a whole lot of other things as well. But this is Pascal. No, that's actually RAT4. It's even better because, of course, this goes to the point. What is more static here? You can use these variables without declaring them, right? And famously, it didn't lose a spaceship. I did check on risks, but if you change that comma to a full stop, then that's a declaration and assignment of a variable do 30 cycles equals 1.15. And this hasn't actually caused spacecrafts to crash, but apparently it did cause errors in trajectory planning that were fixed and removed by someone putting the comma into the right place. As we know, these days talks are really just tweets done in person. And so Sriram was very proud about the finally beating the vocabulary out of the HCM curriculum standard. What vocabulary? Well, interpreted versus compiled. Is Smalltalk compiled? Is BASIC compiled? I'd argue BASIC is compiled. That USDCP system is compiled to bytecodes and it feels static. But if I told you that that's the way Python is implemented, you'd say that's a dynamic thing. What's going on? Well, Anyway, after doing the ZX81 thing and doing computer science, and actually this I got, believe it or not, from the public library. Just before I started university, it must have been, for some reason, my municipal library subscribed to Byte magazine, and here was Byte magazine, and this great picture, and of course, Smalltalk, which you can still get today for aficionados. This is not Smalltalk 80, which has actually caught me out. This is actually Smalltalk 78, and you can get Smalltalk 78 the way you get anything else in the entire world, by going to your favorite search engine and typing in Smalltalk 78. And so this is actually a Java implementation of Smalltalk 78, which will actually run various important Smalltalk 78 programs, notably Alan Borning's ThingLab, which of course invented, what do you call it these days, object constraint? No, it's not. Functional reactive programming, that's right, yeah. Anyway, sorry, right. Smalltalk 78. We're declaring a class. We've got to declare a class here. The way it works in Smalltalk, basically anything from 76 onwards is you have this editor here. We're going to fill in those fields and hit go. And so, you know, we can do that there. I think I've said, okay, there's a definition of one. That's a point class. It's got fields X and Y. I have to declare my fields before they're used. What? That's not, is that dynamic? If I declare a method like this, for example, here is the classic one. Here is a method to return X. And as you can see, Smalltalk 78 is not bound by the constraints of ASCII. For you people want to think it's going to be great when we can really use non-ASCII characters, the answer is yeah, and this demonstration would have been slightly more interesting if I'd worked out how to type the damn things. It's dynamic if you're APL and you can't actually type your program, I don't know. Anyway, so what I tried to do here is edit this. So now we have a new method called XX and it's going to return the value.
You have to use that.
I have to use this.
Very close.
Very close. Right, so the entire previous half of the talk is scrambled. And I got to...
It's fine.
All right, sorry. I don't really... Yeah, okay. I've got to use this. Right, so there we go. Now what we're doing, and if we say accept that or whatever, compile, actually I think the menu item on this version was compile, we get that. Which says, oh, do you want to declare this as a global variable, XX, which means I can't find the current variable. So Smalltalk, a dynamic language, won't actually let you misspell the name of a variable. So it's like, it might be dynamically typed, but it knows something about the structure of your program. It's not, I was going to say it's not dynamically scoped, and which is the overloading dynamically scoped in at least two different ways, but I mean, you cannot just magic variables out of the air by assignment the way, for example, you can in BASIC, or the way you can in Python or various other bits and pieces. How far can we actually go? How mutable, how random, how Turing award-winning can our language be if it really is going to be dynamic? I mean, obviously, syntax checking is good, right? Yeah? Syntax checking is good, unless, of course, you are one of my personal heroes. Here is a small program in a programming language that we probably, frankly, everybody in this room has used this month, yeah? Everybody? Right. And especially, what's best about this, of course, is especially, am I allowed to say this? Especially the Popple guys. Especially, you'll never, ever find a Popple guy using Word or something, whereas occasionally there are still papers that sneak in. You know, so, right, anyway, what's the point of this? Well, there it is, okay. There's a program, it's just defining a function called foo, and it ends, and we run it, and it's evening, and it's morning, and there we go. It's gone, yeah? Great. What's the problem? Well, here's a slightly longer program, and in this slightly longer program, we're actually going to call that function or macro or whatever the fuck it was. And when we do, we get this. Yes, we get a crash. Okay? Is crashing like this actually what makes a language dynamic? Because the thing here is that this is actually a syntax error. Illegal unit of measurement, point inserted, because I typed IX instead of PX or PT or whatever. Or IN. There's no latex unit IX, and my definition had it. But what this shows is that TeX, as we all know, TeX programs are not actually parsed before they're executed, at least not in any sensible sense of the word. And you could say, well, of course they're not, because it's a macro system, and the answer is, remember what Sriram said about interpreted versus compiled? Well, that's an implementation. You know, just because Don Knuth, may his name be praised, implemented this as a macro system, doesn't mean that that's an excuse. You know, it doesn't necessarily mean that's an excuse for the fact that, well, here is a typo in your program, which is only ever going to, you know, it's a syntax error in your program, which is only ever going to appear should execution happen to get there. Right? And this is the way we are supposed to present all our functional mathematics and all this kind of thing. So just pointing it out. There was actually an Australian attempt, various attempts, to do to do typed versions of LaTeX, or at least typed versions of layout languages where these kind of things would be impossible. You know, could you really have a publication language where the syntax errors were all detected before it started typesetting? Do you think you could? Do you get a PhD for doing that? I don't know. Does it matter? Well, that's a separate question. Does any of this matter? I was hoping to be more interactive, and I was hoping to spiel a bit more about, what's the line? Improvisation in terms of languages. This is a rather long sequence, so, you know, there's the question, what about dynamic definitions, dynamic dispatch? I do come from the object-oriented side, which means I gesticulate to Simula. And, you know, we all know that Simula has inheritance, and the whole point of that is that you might have any of these objects, A, B, C, or D, and you can stick them in and it will work. But is Simula really a dynamic language? Because, you know, you had to use a file editor and you had a static compiler, but it's doing this dynamic dispatch thing, right? Well, once I got over the byte issue, I found in the basement of the university library, which was generally used by amorous couples for other purposes, but I looked at the computer science books, and I found this one, Smalltalk. Smalltalk, a dynamic language. It's clear, it's simple, it's easy to operate, yeah. Do I know what that is? That's the inside of Smalltalk. It's the metaclass hierarchy. I used to be able to recreate that from memory. Anyway. What's this things got to do with being dynamic? Being dynamic does clearly not necessarily mean things are simple, and it clearly doesn't mean that you can have incredibly complicated class hierarchies, and I haven't got the slide in, but you could imagine the art of the meta protocol book here in this point in the slide. Okay, I actually did a bit of Smalltalk. I did quite a lot of self. This is a cool bit of self. This is actually the definition, this is the definition of if that the self compiler had, and because some very clever and now unimaginably wealthy people implemented self, Urs Herzley and Craig Chambers, particularly Urs, this definition was actually taken by his compiler and basically went as fast as anything could at the time. Well, that's all right, and so if you think about, let me see, Smalltalk, effectively what that meant at a very high level, if you think about a meta level, if you've got objects in Smalltalk, you've got a get superclass method, it returns something that's an object. Nice paper by Dave Ungarn Gila-Bracher, which points out that the self-design, what we now have as mirrors, is in fact you separate out the meta level in terms of the objects that implement it. So if you call get superclass or get mirror, you don't get something that is in some sense in this domain, you get a separate object that is off in a different domain, and they try and cut out some of the recursion there. How well it works? Ooh, don't know. When do I need to stop? In a few minutes. Self has its problems. I'm not going to go into them, but late versions of self, by the way, have a subclass me button, when the entire point of self was programming without subclasses, or programming without classes. We're going to program with prototypes. You can talk to me afterwards. Which part of this didn't you understand? Things like JavaScript goes on, and in some sense this is more dynamic than self. What I'm saying here is that, you know, even if you think about object-oriented languages in this similar Smalltalk, self, I'm going to say that Newspeak in this thing comes as a bit of a throwback. JavaScript, whenever you do assignment, it just dumps it into the lowest object, whereas, well, you know, self is like Smalltalk, and as we've already seen, it only lets you assign to variables where you've actually declared the damn variable first, because you don't want your spacecraft that's being programmed in Smalltalk to sort of disappear off into the wrong direction. But JavaScript will always do an assignment, and it always does it to the lowest object, and in some sense that is being more dynamic than self and Smalltalk and similar. We all know Dijkstra would have said this. Right, so I was going to sum up this bit, and my slides are going to do it for me. Basically, I think if you even think just about this category of object-oriented languages, and you want to say, are these things dynamic or static, and you want to do this in terms of the if you like, the structure or the meta model of the language. It's not as simple as saying, well, they are dynamic or they're not dynamic. In fact, we can see almost different kinds of object-oriented programming through 4 or 5 generations about what needs to be defined where, what can be changed where, what happens together, and what happens apart. I will skip this because that's basically a list of the things. Ooh, why have we put this here? Oh, that's right, here we go. This is our Smalltalk 78 again, and I'm going to write one foo, which is going to call foo on 1, or something. And I can, look, I tell it to compile. Actually, I don't, I have to tell it to do it, but anyway. And what do I get? I get this. Okay, the crash. The things that people in Popple land, I shouldn't say this, but what the hell, I'm exhausted. The people in Popple land upbraided Smalltalk and object-oriented programming for not being type-safe precisely for this reason. That you could do a call, in this case I tried to call foo on some integer, and message not understood. There was not a definition of foo for that integer. Right? And this was, for quite a long time, a stick used to beat programming languages and object-oriented people with by people who want to publish in other conferences. So, I'm going to show you another language. And it's got 2 important features. And the first important feature is that it doesn't have any real static type declarations. Okay? There we go. We're declaring some classes. For some reason, this language says data instead of class, but that's declaring some record structures. It's not actually really declaring the types of variables. I'm going to pretend that anyway. There we go. And this environment actually is really pretty dynamic. So I've got my definitions here, and I can type code in here, and it updates it, and it shows it the value. So, for example, if I accidentally change the way a dog barks to Rolf or something, that other code gets executed, it gets updated live, and basically immediately as soon as I do it. That's pretty good. That's pretty interactive. That's pretty tight. Okay, and what's more, this system is clearly dynamic because what if I do that? What if I ask a cow to say something? Oh shit, I haven't given a definition. What do I get? What's that red thing there? Oh look, it's this crash. Okay, it is this crash. It does say non-exhaustive patterns in function say, but what this really means is does not understand. The cow does not understand the message say. Maybe things are around the other way, but that's it. Okay, and I call this crash. I did actually check it yesterday on the most up-to-date version of this language. If a dynamic language is a language that can have precisely this kind of crashes, and if those sort of languages are bad, well, what is this language, by the way? Anyone know? That's right, it's the H word, Haskell. And another thing people will say about dynamic languages, well, you can just continue on. And the answer is you can just continue on, because from here, if you then give that definition, it all just carries on. It will run, it will update, the exception will go away, and on it goes. And yes, that was Haskell. That thing is still there in the version of Haskell I was using, which I actually reluctantly love, which is Haskell for Mac. And one of the things that I discovered I loved about it, which is really weird, was because, it seems odd to say it, but I'm going to say that there's a bit of the same sort of flavor that you find in Smalltalk code. I'm not sure whether that's a good thing or not, but there's not very much line noise, and stuff happens on spaces, and I'd probably still prefer Smalltalk over Haskell. But maybe if Haskell can interact like this, and importantly, can provide these sort of crashes when things aren't defined, which is a hallmark of dynamic languages, which let's remember that since approximately 1995, so in other words, before many of the people in this room were born, it was absolutely impossible to create this kind of crash in Java. Okay? Absolutely impossible to do this in Java. You might call it a type error. But that would mean that Haskell has got dynamic type errors that Java doesn't. Let me just say that again. Haskell today, as defined in the standard, admits dynamic type errors that Java never has. Yeah, tweet that, you folks. Anyway, What's going on here? Well, part of it is as Tudor puts out again, all my talks just come from tweets, there is this issue of static versus dynamic programming languages. Sriram points out it's about the implementation of the language, and Tudor's saying it's also about the IDE. It's also about the IDE. And I think the small talk and self for me line is it also about, in some sense, where do you draw the lines? Do you say this operation may be adding a new field to a class? Because in JavaScript, well, actually I don't know what JavaScript does today, but in JavaScript 5 years ago, you did an assignment and it added a new field into the instance. I believe in JavaScript today, if you do some kind of structural freezing of the instance, that won't happen, but if you don't, it still will. That seems pretty dynamic, but then again, Smalltalk programmers don't really mind that they don't have to do that and quite like the idea that they can't randomly invent variables in their programs and don't really mind having to go and say, oh, look, I'd like you to add a variable, declare a variable for this method, declare a variable for this block. And I've been told to finish up, but I did start a couple of minutes late. I find myself saying this a lot. Ontogeny recapitulates phylogeny, which means, if you want to understand how something is, you have to understand how it evolves. Originally, it actually meant that you could look at the development of the embryo, and the idea was that would actually mirror the evolutionary descent of a particular species. I'm kind of generalizing it a bit, of being slack about it, and just saying there are a lot of things we can understand which happen only because of the way they happen, because of the way they came about. So whether it's things like the fact that Daphne has one if statement one if statement without a then clause, but an if expression with a then clause. That doesn't make any sense to me, at least. Why would you do it that way? Well, the only way you can think about it is because, well, they took one from Haskell and they took one from C#, and then they didn't think about whether this was consistent or if you'd ever want to change an expression into a statement or a statement into an expression. If you want to think about why JavaScript is the way it is, well, we want to think about why even Smalltalk is the way it is. You have to think about this. And kind of regrettably, all languages are dynamic in the sense that, I did have some extra super notes that I didn't really get to. All languages are dynamic in the sense that, well, in at least two different senses, I suppose. One of which is we are programming with them. And these days, any language from, well, ironically, even the more hardcore formal things, the Cox and the Agdas and the Daphnes, are really leaning in to highly interactive programming environments in the way in which, kind of might be surprising. On the other side, there are languages we think of as dynamic that have what we could consider static implementations, etc., etc., etc. And I'm going to stop there because I was asked to stop to leave nominally some time for questions, but I'm not sure whether I have or not. Thank you for your time and patience.
Thank you, James. So we have time for one or two questions. Come on, don't leave me alone with that.
So I guess I'm just curious, if we accept that all languages are dynamic, beyond the fact that we should let more dynamic language papers into Popl, what do you feel like are the implications of that? If once we all accept the premise, what then should we be doing? Are there different ways we should be thinking about how we design languages or tooling, or is it just sort of an epistemological thing? We should be more willing to not let language boundaries define how we think about ourselves, since it's all sort of the same thing anyway.
I'm not necessarily saying it's the same thing. Maybe in some ways I'm, as the French would say, denying the binary. Or there are even politicians that say that now, which is a bit distressing. It did turn out that all those French existentialists were right and that truth didn't really exist. But anyway, so part of it I think is saying, yeah, well, there's implementations, there are IDEs, there are those which in some sense are also implementations. There's the question of what, where you draw the line between, what's reflexive and what's not. And it's perhaps more useful to think about things in those terms. And the other thing I think is it's actually better, and it took me a long time to work out some of this shit, because I didn't really know Haskell, and I couldn't believe that Haskell did not have the completeness test on pattern matching. And again, I understand why it didn't. It didn't because at the time they didn't want spurious errors if they were using guards on their programs and everything was covered anyway. But, you know, so I think part of it is actually kind of looking at what actually happens in actual languages as used in actual IDEs. And I'm not saying you have to do empirical studies, you may have to do human studies, but not necessarily I don't think you can do double-blind studies, but you know, just being honest about the fact that, oh yeah, well, Haskell, as currently standardized, nobody's contradicting me, doesn't check that all your pattern matches are covered.
You get a compiler warning.
You do now! You do now! You didn't. You do now if you're running the right version. I did say I'm pretty sure I was running the most up-to-date version of the Haskell thing. And if I go screaming back to here, wherever it was, okay, that didn't give me the warning. Maybe it just suppresses all warnings. I'm not sure whether it does or not, but it didn't give me the warning. So this is a Haskell system that you can and should actually pay money for because it really is pretty good if you've got a Mac.
Okay, a very short one for ending this.
Sorry.
More of an observation, James.
Excellent.
So, and kind of in support of your thesis. All languages are interpreted. The thing in my bag here is an x86 bytecode interpreter. It happens to be pretty fast.
Yep.
But the rest is all the degree of partial evaluation. So it's all a matter of degree, not really of kind.
I think so.
Okay, thank you very much for this presentation.
Thanks again for your time and patience.